Hi everyone, this is our semester project for Dr. Davis's Manufacturing Design Studio course. This is John Janowitz and the other members of the team are Clay Busby, Michael Glasgow, and Peter Shin. Our group chose the second option to tour a facility where we could witness a manufacturing process we learned about in class. We took a tour at Conwed Plastics, a subsidiary of SWM International, located in Athens, Georgia. Our tour was led by their senior project engineer, Glenn Petco, on November 16, 2021. Conwed Plastics manufactures plastic nets that are primarily used for erosion control at construction sites and in residential areas. On our tour, we witnessed the extrusion of the plastic threads used to make the nets and the process used to strain harden the nets before they are ready to be delivered to customers. We did not have any hands-on involvement during this process due to safety concerns. We only received permission to photograph and take videos of the extrusion process. We will show that process first and explain the photos and videos we took, and then explain everything else we saw and do our best to find pictures similar to what we saw online.
This is a diagram of what the inside of the plant was like. The extrusion process we covered is that red block in the bottom left corner. The three rectangles on the right side are the three main production lines. The green rectangle is the mesh formation line where films of plastic and the plastic threads we saw get extruded are manufactured into the plastic nets. Unfortunately, Glenn did not take us through this line in detail, but we did get to go through the entire strain hardening process that is done to the erosion nets. First, we toured the production lines that are responsible for strain hardening the plastic nets. This is the part of the tour that we were not allowed to film or photograph. The purple rectangle circled on the diagram is where the nets are stretched lengthwise, like shown here. The nets are strain hardened by being stretched out on oiled coils. These coils are heated by a large natural gas flame that burns underneath the production line. They opened up a door on the side of the machine and we are able to look up and see a huge flame that heats the coils. This line is able to stretch out these nets at 1,200 feet per minute. At the end of this line, the netting is automatically rolled up into spools, and their machinery can make a roll with up to 100,000 feet of netting on it. The rolls are able to detach automatically and can then be removed and stored by plant employees. The next production line we saw is where the nets are stretched along the width of the product, as shown here. This area of the plant is represented by the rectangle on the far right hand side of our diagram. The nets on this line can start at just 40 inches wide and then be stretched out to as wide as 40 feet. This is done by pushing the nets onto a chain with pins coming out of it, like similar to the one shown here. The nets are stretched by the chain spinning at up to 2,500 meters per minute, which is much faster than the previous production line. Any parts of the netting that are stretched past the pins on the chain are automatically cut off, removed from the production line, and then chopped up to be remade into pellets at a third-party site. Over 90% of the netting trim and waste at Conwed Plastics is able to be remade into plastic pellets for later use. There can be major errors on this line that cannot be fixed automatically. If there is a weight variation in the netting, which is often caused during the extrusion process, then this can cause large portions of the net to be unstretched or cause large tears in the netting while they're being spun on the chain. If this occurs and the damaged netting cannot be removed automatically, it has to be pulled out of the system manually by employees of the plant. Now Clay is going to take us through the extrusion process, which is the part of the facility that we were allowed to photograph and film.
Our tour started by walking to the upper level where the pellet hopper is located. The process starts here when plastic pellets are loaded into the hopper. The hopper automatically weighs and sorts all of the different plastic pellets. Each product has a different ratio of colored pellets. After the pellets are sorted to make the correct ratio of plastic for the product, they are melted in a cylindrical heater core. Inside this heater core, there is an auger that pushes the melted and unmelted pellets through the machine. Once the pellets are completely molten, they pass through a metal screen to remove impurities. The plastic stream is then split up into 4 outputs, where they are extruded through a metal die plate. This forms 72 strands of plastic which fall downward to be cooled by a stream of air. Next, the strands are passed over the rollers to stretch and strain harden them. After stretching, the next step is to combine the strands into individual threads. The strands are again passed over rollers which heat up the strands slightly through induction. This allows the strands to be combined into one thread. Each thread is made up of these 72 strands. Combination occurs when the strands are all running parallel to each other. They are still heated by induction when hot air is blown at high velocity so that they are randomly intertwined together. Once combined together, the threads are then rapidly cooled with air and then spooled onto large rolls ready to be used by the end consumer. Any waste produced in the process of making these threads will be taken out, chopped up, and recycled by a third-party vendor.
So that's a summary of everything we got to see at Conwed Plastics. Although we were not able to film and photograph everything we saw, we are still very grateful to Glenn and everyone else at Conwed for inviting us to the plant and taking us on a tour. It was very informative, and we all got to learn a lot about what it's like to be a manufacturing engineer, and we got to see some of the processes that we have been learning about this semester. So thank you to everyone at Conwed Plastics, and thank you to Dr. Davis for a great semester.